Today we're going to graph equations using slope. So just like always, we're going to review. The slope is the rise over the run, or you can use an equation. It is the change in the y value and the change in the x. And our equations are written in the form y equals mx plus b, where m is the slope and b is the y-intercept. So if we keep this in mind when we are going to graph, I'm going to give you a couple of examples. So we're going to work a few together. Remember, our equation is written in the form y equals mx plus b. So if I have given you the y-intercept is -2 and I have given you the slope, you can easily write the equation of the line down. And from those two pieces of information, we have everything we need to make a table or a graph. So we would start, this would be my starting point, would be at -2. So we come over here on the graph, and we put a nice big X for our starting spot. And this is the rise, so the rise is 1, and the run is 5. So I'm going to go up 1 and across 5. So we go 1, 1, 2, 3, 4, 5. Now in my class, you will be expected to have 3 dots on the graph. And so if we need to put the other point back here, you need to realize that that means we're going to go the opposite direction. So I'm going to go down 1 and backwards 5, or down 1 and to the left. So down and then 1, 2, 3, 4, 5. Because we know that a negative and a negative are a positive. That's why this fraction, or slope, is equivalent to positive 1/5, because 2 negatives make that a positive. And so that way, the line is still going uphill because the slope is positive. So let's try one where we have something slightly different. So let's come down here and look at a slope of -5 and starting at -3. So we have y equals -5x minus 3. Notice that even though in the equation I have a plus b, there isn't any reason for us to put plus a -3. We know that adding a negative number is the same as subtracting a positive number. So go ahead and simplify it so that you only need one operation symbol. You don't need both the addition sign and the negative. So again, we're going to start with -3. So we're going to come down here on the -3 and we're going to make that mark. And then it says we are going to go down 5. And if I need to put the rest of the fraction on there, that would be a 1. So if there's no room to go down 5, we would rewrite that as a positive 5 over a -1. And so we could go up 5, 1, 2, 3, 4, 5, and backwards 1. And if I needed to do it again, 1, 2, 3, 4, 5, and backwards 1. So my dot would be clear up here, kind of off the graph. But it would still give me the idea of downhill. See how it's going down a hill. Let's try another one in the same format. We are starting at 3, so I'm going to rewrite my equation here as 1/2 x plus 3. We will start at +3 this time because we have a positive number and a positive 1/2. So that would be up 1 and over 2. Up 1 and over 2. And if you only needed to give 3, that would be perfectly fine. However, if you're checking with a partner, you will realize that going down and over 2 to the backwards direction also gives me that positive uphill slope. So your partner may have chosen these dots like you did, or they may have chosen these 3 right here. Either one of them is correct. It would keep going. There's an infinite number of points that you could eventually find. Now that's one way for us to get started. Sometimes they're going to already give you the equation, and so you're going to find that it is just as easy to go ahead and start there. And so again, this one is very similar. I'm going to try number 2 down here because it looks a little different. Not too bad. But we're going to start at 3. There's my start number. And this is my rise. And this one is my run. So that would be 1, 2, 3, 1, 2, or 1, 2, 3, 1, 2. See how I'm just counting out the boxes? Down 3 and backwards 2. Now, some people get a little concerned. Let's say, for instance, that I was going to do the same kind of thing, only what if I wanted to use one that had a 0 here instead? And I'm just going to go ahead and make that so that I have y equals negative 5x. And so if there's nothing there, then we know the starting number is 0, which means it's going to start at the origin. So we're going to have one that starts right here at the origin, and we're going to take it down 5 and over 1. So down 5 and forwards 1, because remember the 1 is positive and positive directions go in the forward direction. And if I needed to do it again, it would be up 5 and backwards 1, so that I could get the negative slant going on my graph. Now those are the most common. As we start moving up into the high school class, I will tell you that we will be giving you equations that look like this. And so the first thing you have to do is rewrite it so that it is in the slope-intercept form. And so I'm going to go ahead and subtract my 3x. And like I said before, when you're rewriting them, if you go ahead and rewrite it in the y equals mx plus b format, it will make things a lot easier for you so that you'll be able to graph it. So again, I'm going to start down here at negative 4, and I'm going to go down 3, which I cannot do. So I'm going to go up 3 and backwards 1, and then up 3, 3 and backwards 1. And I could keep going if I needed to, but 3 dots is sufficient for me to know that you know which direction that the graph is going to go. So again, if you need to, you will have to go ahead and rewrite. So there again is no shortcut to this. We have to divide everything through by 3. And we have negative 2 over 3 x minus 3. So we're going to start at negative 3 because the y-intercept is always my start number, and this has to go down 2 and over 3. So 1, 2, 1, 2, 3, or up 2 and backwards 3. And so my line is again going downhill. Okay, so again, let me recap. Slope is the rise over the run, and the starting point is the y-intercept. So if I were going to write this equation right here, this would be your start, and then you would have counted up 1 and over 1. So that's how we're going to graph. Great job today.